Hi there, welcome to video course Advancement with Security Automation using Ansible. We are in section number 5. In this section, we will cover these topics: security governance concept and how to use Ansible to achieve this, Ansible Tower credential for sensitive information storage, Ansible Tower type of user, importance of continuous hardening for being compliance, and we will cover AWS use case for EC2 security group hardening using Ansible Cloud Credential and AWS EC2 resource group, port scanning using Ansible, finding the vulnerabilities and patching of the system, Ansible source code, and lab example. Let us jump to the first video of this section, how to enforce security governance with Ansible, and in this video, we are going to take a look at these listed topics: security governance concept, the protection triad, Ansible Tower credential for storing sensitive information storage, Ansible Tower type of user, importance of continuous hardening for being compliance. We will cover AWS use case for EC2 security group hardening using Ansible Cloud Credential and AWS EC2 resource group. Security governance. The basic definition is doing the thing right with the proper policy and process in place in your organization, which typically revolves in these three areas. Confidentiality, the concept of keeping private information away from the individual who should not have access. Ansible Tower Credential allow access for different destinations like SSH access to machine, SCM credential to access GitHub or Bitbucket. For example, AWS secret key information is kept encrypted. Your SSH private key information is kept encrypted by the Ansible Tower credential. If you are not using Ansible Tower, then encrypt all the sensitive information using Ansible Vault command. Integrity. The concept of integrity means the data is consistent and it hasn't been modified. This modification can result from access by an authorized or unauthorized individual or process. Integrity must also prevent modification of data while in storage or in transit. For example, Ansible Manage Playbook using source control only with SCM update option will remove any local modification. Another example could be utilizing the Ansible module for idempotent. Availability and auditing. The concept of availability is pretty straightforward. You should have reliable and timely access to data and resources you are authorized to use. It has 5A like authentication, authorization, accounting, auditing, and availability. Ansible Tower comes with RBAC support. RBAC control allow Tower to help you increase your security and streamline management. There are three types of Tower user. Normal user, read and write access is limited to the inventory and project for which that user has been granted the appropriate right. Organization administrator, the administrator of an organization has all the right of a normal user as well as admin, read and write permission over the entire organization and all of its inventories and project, but does not have those level of access on content belonging to other organization. This level of user can create and manage user. Super user. A tower super user has admin, read and write permission over the entire tower installation. A super user is typically a system administrator responsible for managing tower. In this lab, we will discuss a case study on the AWS EC2 security group for the production deployment. The EC2 security group is subject to modification intentionally or unintentionally. All the changes on the security group need to bring back in the same state to ensure that we have a proper security control in place. For example, the following security group which is present in AWS is being modified manually. It is not supposed to change without a formal change control process, which impacted several production instances. To be in compliance with your security posture, The Ansible Tower is used for managing the AWS resource group. At the very first step, the Tower admin has created AWS credential by specifying the name AWS credential, description AWS credential, organization select the default organization, and on the type select Amazon Web Services. Provide the access key and secret key information and save the configuration. The AWS credential is successfully created. Now we will create the inventory for managing the AWS. From the Tower Inventory tab, click on Add to create a new inventory. Provide the detail like name and description to AWS inventory. This example used default organization and save the configuration. On this inventory, we are going to create AWS resource group. Click on Add Group, name and description to AWS EC2 Security Group Hardening, and on the source, choose Amazon EC2. Choose the cloud credential to AWS credential which we have created recently. Provide the region where the production systems are located. On the instance filter, this can be used to group the instance based on various tag options. Our interest is to protect the AWS EC2 production environment, and the tag name is defined as Let's Encrypt in AWS. Select the group by option and save the configuration. Once done, start the sync process. This will trigger an Ansible job which will use Ansible dynamic inventory concept and will find all the IP which matches this criteria. The sync process has found one IP address in AWS which fulfill the selection criteria. Click on this host IP address. This will give you the detailed information of this host in the Ansible variable section. Now our inventory and credentials are ready. Let us go back to the Ansible source code for this example. In this playbook example, we will typically be using the following pattern for provisioning the step: host, localhost, connection is local, and an EC2 role is defined for this playbook run. Under the task directory of the EC2, the main.yaml file is included with one task, EC2 sec group production.yaml, which is performing these tasks. This example uses Ansible Cloud Module EC2 group which maintain a EC2 VPC security group in the AWS, and ingress rule and egress rule are defined for production EC2 web server group. Now go back to the Ansible Tower and view the Ansible Job Template for this demo. Under this template section, a EC2 security template is defined. Click on this to verify the configuration. This template uses ec2.yaml playbook file from the project Ansible to advance it with security automation and uses AWS inventory with the AWS credential in the cloud credential. The job type is run here. Now go back to the job template and run the job. An Ansible job is scheduled for running. The play recap shows the job went successful. If we go back to the AWS security group for the verification, the ingress rule of this security group bring back to the desired state. Now we need to enhance this security posture by scheduling the Ansible job template on a regular interval. Go back to our working job template and schedule the job by clicking on this icon. For this demo, I have created a job template with the name Production Security Group Hardening. Let's visit the configuration. This job will run for every 30 minutes and it will never expire. By doing this, we are ensuring that we have necessary security control in place to make the system in consistent state. It is important to schedule all your hardening stuff to achieve the compliance. The Ansible job shows that this job template is running for every 30 minutes. Congratulations! We have successfully completed this video